positive, a program contains the Boolean expression math.pow x, 0.5 equals math.square root of x. And even though x to the 1/2 is mathematically equivalent to square root of x, the above expression returns the value false in a student's program. Which of the following is the most likely reason? So for number 8, the most likely reason that this happens is because when the power function and square root function run, they run in different ways, and there could be round off error when they're both calculated. So the answer to number 8 will be D. And number 9, what will be the output in the following poorly formatted program segment if the input value for num is 22? So for number 9, you plug in 22 for num, and you get, if num is greater than 0, so 22 is greater than 0, so it goes into the if statement. And from there, it enters the second if statement. If 22 mod 5 equals 0, and we know that 22 mod 5 isn't 0, so it never gets to this line over here. And after that, it skips straight to the else, so it just prints num, which is 22, and then is negative. So number 9 will be D. Number 10. What values are stored in X and Y after execution of the following program segment? So first you have X equals 30 and Y equals 40. So then you have if X is greater than or equal to 0, and we know that 30 is greater than 0, so it enters that if statement. And from there, it goes into the second if statement, which says X is less than or equal to 100, which it is because X is 30. And then it goes into this if statement. So Y now becomes the X value 30 times 3. So Y is now 90. And so it doesn't go into the next if statement because 90 is not less than 50. And because we already entered this if statement, it completely skips this else statement, and it from there the program stops there, and you get X equals 30 because X was not changed through the whole process, and Y equals 90. So the answer to this question is A. Okay. Number 11. Which of the following will evaluate to true only if Boolean expressions A, B, and C are all false? So the only one here that will evaluate to true if they are all false is answer choice C, because even if a single one of these 3 are true, then the whole, even if a single one of these 3 are true, the entire statement will be false because the inside will be true because they're all ors, and the not outside of the parentheses will make the true a false. So all 3 of these have to be false in order for the entire thing to be true. So the answer to number 11 is C. Number 12. Assume that A and B are integers. The Boolean expression not A is less than or equal to B and A times B is greater than 0 will always evaluate true given that. So in order for this entire expression to be true, both sides of the equation have to be true. And so for the left side, A has to be greater than B in order for this side to be true, because when A is greater than B, the inside becomes false, and the not makes the left side true. So we know that A has to be greater than B. And here we have A times B is greater than 0. So we know that A is already greater than B. And in order for this entire side to be positive all the time, B also has to be a positive number. And A is greater than B, so they will both be positive numbers. And that way both sides will be true, and the entire AND statement will become true. So the answer to number 12 is D. Number 13. Given that A, B, and C are integers, consider the Boolean expression. Which of the following will guarantee that the expression is true? So choice A says C is less than A is false. So if this part of the expression is false, then this entire AND statement inside of the parentheses will be false as well. Because if one side of an AND is false, the whole thing becomes false. And so if the inside of the parentheses is false, the not will make the entire right side of the equation true. And since we have an or here, and for an or statement, if one side of the expression is true, the whole thing is true. And C is less than A will make the entire right side true, making the entire or statement true as well. So to make the expression true, C has to be less than C is less than A is false will guarantee that the expression is true. Okay, number 14. In the following code segment, you may assume that A, B, and N are all type int. So what will happen if A equals B is false? So if A equals B is false, then A does not equal B. And so this side of the if statement is met. That condition becomes true if A equals B is false. And so now we have to look at the right side of the if statement. And us knowing that A does not equal B doesn't tell us anything about the exact values of N, A, or B. So we can't determine if it will be greater than or less than 90. So it's possible that it's greater than 90, and if that's the case, then statement 1 will be executed. However, if it's not greater than 90, then statement 2 will be executed. So the answer to this question is C, because since we don't know what happens to the right side of this expression, either statement 1 or statement 2 will be executed. Number 15. Given that N and count are both type int, which statement is true about the following code segments? So in these code segments, we have a for loop for the first one and a while loop for the second one. So what the first one does is it starts at count equals 1 and goes on to a certain number while adding 1 to count every time the for loop reiterates. So, and all it does is print count. So this for loop basically just prints every number from 1 to n. And what the while loop here does is start at count equal 1 and goes up to n and prints every number from 1 to n as well. So both of these do the exact same thing, and because of that, number 15 is A. Number 16. So it says the following fragment intends that a user will enter a list of positive integers at the keyboard and terminate the list with a sentinel. And it says that the fragment is not correct, which is a true statement. And so what's happening in this code? We know that int value equals 0, and the value of the sentinel is a final value, which equals negative 999. And then we have a while loop that says while value does not equal sentinel, and then it goes through a code to process the value. Value equals io.readInt. So it reads the user input after the code to process the value. So it doesn't have an input, but it processes the value. It processes the value before the user is able to input anything, and so the value is just 0 every time it runs. And because of that, the answer will be C, because the answer will be D, because the code will always process a value that is not on the list, because it will process the value 0 and the user won't be able to input their own value. And so to fix this, the programmer should have put this statement outside over here in order to let the computer first take the value and then process it. So the answer to this question is D. Number 17. Suppose that base 2 binary numbers and base 16 hexadecimal numbers can be denoted with subscripts, as shown below. And it asks which is equal to 3D hex. So for this question, we have to find what 3D hex is equal to. And in order to do that, we do 3 times 16 to the first power, because hexadecimal is in base 16, and to that we add D times 16 to the 0th power. And once we do that, we get 48 for this, and we get 13 for the second part. And so in total, we get that this number is equal to 61 in decimal. And now we have to convert this decimal number into a binary number. And in order to do that, we know that we can write 61 as a sum of descending powers of 2. So you can write it as 32 plus 16 plus 8 plus 4 plus 1. So we know that 32 is equal to 1 times 2 to the 5th. 16 is 1 times 2 to the 4th. And 8 is 1 times 2 to the 3rd. 4 is 1 times 2 to the 2nd. 1 is 0 times 2 to the 1st. And so once we add all those together, we get 1, 1, 1, 1, 0, 1 in binary. And so the answer to number 17 is A. Number 18. So number 18 says, a common use of hexadecimal numerals is to specify colors on web pages. Every color has a red, green, and blue component. In decimal notation, these are denoted with an ordered triple x, y, z, where x, y, and z are the 3 components, each an int from 0 to 255. And for example, a certain shade of red whose red, green, and blue components are 238, 9, and 39, and 63 is represented as 238, 9, 63. In hexadecimal, a color is represented in the format RRGGBB, and where RR, GG, and BB are hex values for the